can you solve this Olympiad question that, surprise, surprise, came out in a 2015 Olympiad paper? So we're looking for the maximum value of xy when we know that x squared plus y squared plus 3xy is equal to 2015. Now, generally, when we're looking for maximum values, if you know some more advanced maths, we'll use differentiation to do that. But this is a year 10 Olympiad question, and you're not expected to know differentiation yet. So the other thing that is connected to this is when we're doing quadratics, completing the square, that tells us our maximum and minimum points. And this is a quadratic, so it might be related to that. But also, we're looking for the maximum value of xy. Maybe it makes sense just first to put xy on its own side so that we can potentially try and find that maximum value. So we can just do 3xy and subtract the x squared and the y squared over to the other side. It's equal to 2015 minus x squared plus y squared. Great. So we know that we want to make this part as small as possible, and that will maximize the left-hand side. If we're subtracting less from the right-hand side, it's going to make this side as large as possible. But it's actually not quite that simple because, of course, our x and y values here are connected to our x and y values here. So as we're looking at this, thinking what we could do next, we may start to think, well, what if we could try and factorize this into something? But x squared plus y squared doesn't factor into anything. But often we can kind of manipulate it a little bit by adding the thing that we need so that we can factorize it. And this is close to a perfect square. So what we can do is just add our 2xy to both sides. This does become a perfect square. And what I'm going to do is, because we're adding 2xy, but I'm putting it inside a bracket, which is a subtraction in front of it, we're going to need another subtraction to cancel that out. So it's going to be x squared minus 2xy plus y squared. Great. So now we can go ahead and factorize this. So we get 5xy is equal to 2015 minus x minus y squared. Fantastic. And we know this x minus y is always going to be positive or 0. It cannot be negative. So we want to make this 0, basically. And that's going to maximize our left-hand side with a 5xy. And we're looking for the maximum value of xy. So if this is 0, x minus y is 0, then x equals y. And we have that 5xy is equal to 2015. So when we divide that by 5, we get xy is equal to 403. And by doing that, we'd also know that x and y are equal to each other and they're both the square root of 403. But actually, we're done. We have found the maximum value of xy, which is 403. And we know that this is the maximum value because if x and y were anything different, this would not equal 0. And thus 5xy would be smaller than 2015. Let me know if you like that in the comments.